What's up, guys? It's Wednesday, March 18th. You guys have a homework assignment that's due by 3 p.m. today, so make sure that you get that picture of that uploaded before then. Also, you guys have a quiz tomorrow. I'm going to keep reminding you about these things. You have a quiz tomorrow, so make sure you get studying. If you have any questions, send me an email or let me know. We can schedule a Google Hangout so you can help you study for that. I'll try and keep doing these as much as possible so you guys know what to expect. But in the meantime, go ahead and smash that like button.
Yeah, smash!
And have a great day. What's up, everybody? Hope you guys are doing well. Welcome to another lecture. Today we're looking at lesson 10.3, composite figures. Now, what exactly does composite mean? The definition of composite is made up of various parts or elements. So a composite figure is a shape that is made up of individual smaller shapes. So what that means is that we have this shape here, which I don't have the area formula for, but I do have a rectangle right there, and I have a triangle right there, which can be broken down into that diagram there. So we take our original shape here, break it into individual simple shapes, and then those simple shapes we know the formulas for, and we can solve for each of those individually, add those individual areas together to get the total area of the shape. So that's kind of the objective for today. That's what we're looking at. So let's go and read this first paragraph here. The figure at the right is called a composite figure because it's made up of simple shapes. To find the area, first find the areas of the simple shapes and then add them together. So when looking at our shape right here, notice that we have 5 centimeters for the base, 4 centimeters for the height of that triangle. So the height of the triangle is 4 centimeters. The base of the triangle is 5 centimeters. Now, how do we find this? Well, if we come back over here, notice that this side is 11 centimeters. This side is 7 centimeters. So all I have to do to find the height, that section right there, is just do 11 minus 7 to get 4 centimeters. Now, how do we get the base right here, that 5 centimeters? Well, again, right here, now let me use a different color. So we have 18 centimeters for the base of that shape. We have 13 centimeters for this section right here. So to find this portion here, all we're going to do is 18 minus the 13 to get the 5 centimeters. That gives us the base and the height of the triangle. So to calculate the area is equal to 1/2 base times height. That gives me 1/2 5 times 4, 1/2 times 20. That gives me the area of the triangle, little t for triangle, is equal to 10. Oh, hold up. Centimeters squared. I'm going to circle it because it's not my answer, but it is important. Now, let's go ahead and calculate the area of my rectangle. Well, the area formula for the rectangle, area is equal to base times height, or length times width, doesn't matter. The base is 18. The height is 7. 18 times 7 gives me 126 centimeters squared. Don't forget units. It's area, so it's units squared. If you forget units, you'll lose points on the testing quiz. So area of the rectangle. I'm going to circle that as well because it's not my answer, but it is important. So since I've calculated the area of the rectangle and I've calculated the area of the triangle here, To get the total area, I'm going to add them both together. So the total area is equal to the 126 plus 10 to get the area of 136 centimeters squared. That's my total area, and that's my answer. So don't overcomplicate this. Just take the complex shape, break it down into easily calculated area shapes, rectangle, triangles, whatever else. Calculate those individually, add them together. That's all you got to do. Don't forget units. Here's a couple of examples. I would suggest that you guys pause the video, try and do it on your own. I think you guys would be able to. But go ahead and do that now. So assuming you pause the video, I'll assume you guys did. Let's go ahead and solve these both together. Let's solve number 1 first. So here's our composite shape. Notice the two individual shapes. I have a rectangle here, and I have what looks to be maybe a square right here. Let's go ahead and calculate those distances individually, the lengths individually. So let's go ahead and start with what looks to be a square right there. So to calculate the length and width, let's take this side, subtract it from this side, and that will give us that distance right there. Well, I have to do 20 minus 15, so that's going to give me a distance of 5 yards. Now let's go and calculate this section right here. To do that, I'm going to do 28. I'm going to take away this 22 yards, and that gives me a 6. That gives me 6 yards. So this is important. Even though it looks like it may be a square, or it looks like it might be whatever shape you think it is, always calculate it to see if it's actually what you think it is. It's always important to double check your work. So we have 5 and 6 for this right here. So it's actually a rectangle. So the area of rectangle 1 is equal to 5 times 6. That gives me 30 yards squared. Now let's go and calculate the area of this guy. So to calculate that area, I got the base of 28, the height of 15. Don't use this height over here, because that's the whole thing. I only want that rectangle. So I do 28, so I'm going to say area of the rectangle 2 is equal to 28 times 15. That gives me 420 yards squared. Again, I'm just going to circle that because it's not my answer, but it's important. So to find the total area, all we're going to do is add them both together. So I do 420 plus 30, and get the area is equal to 450 yards squared. Alright, now let's go ahead and do the next one. So question 2, I have my two simple shapes here. Now this is a square. We can tell because it's 16 and 16, so right away we know it's a square. That's my first simple shape with this composite figure. And here's the second simple shape. Now hopefully you guys can see this. It's just half a circle. So we know how to calculate the area of a full circle. If this was full, I could calculate it. So all you have to do is calculate the area of the full circle, then divide by 2 to get half of it. Now, the one thing we're missing for this circle, we'll start with that one. So let's calculate the area of the circle. Well, to calculate the area of the circle, you need pi radius squared. That's the formula. So you need the radius. Well, what's the radius? Well, if this side here is 16, that would be the diameter. And remember, the radius is half the diameter, so the radius is 8. So to calculate the area of the circle, this is going to give you pi times 8 squared, which gives you an area of the circle of 64 pi feet squared. But that would be the entire circle, right? That'd be the full circle. Now we're dealing with half of it, so what we have to do is just divide by 2, and that will give us the area of the half circle, really, of 32 pi feet squared, which then if you were to multiply by pi, that would give you 100.5 feet squared. So that is the area of the half circle, 100.5 feet squared. Now let's calculate the area of my square. So to calculate the area of the square, I'm just going to do length times width, or side times side, s squared. 16 times 16, that gives me 256 feet squared. That's the area of the square. Now, I'm just going to write this up here really quick. 256, because I'm limited on my space, as are you guys. 100.5. I'm going to erase all this really quick, so go ahead and finish writing it down, or pause the video. I guess, yeah, pause the video. Get it. Just going to erase this here. Just a second. Alright. So to calculate the total area, I'm just going to add them both together. 256 plus 100.5, and that gives me the total area of 356.5 feet squared. That's the total area of this shape here. Alright, excuse me. Now let's look at this example. There's really two ways you could do this. The way that we've been doing it, you calculate the area of this rectangle, then you calculate the area of this square, and then this square, and then add all of them together to get the total area. So we could do it that way. That'd be perfectly fine if you did it that way. You get the same answer. But what we could do is calculate the area of this big rectangle here, and then subtract away. Let's see if I can figure this out. Oh, okay. Subtract away that portion there. So calculate the area. There we go. Calculate the total area of this big rectangle. Subtract away that portion, and you'll be left with the area of the shaded region. So let's first start with the area of the rectangle. Base times height. Base is 12. The height is 9. So the area of the rectangle is equal to, where am I, 108 inches squared. Now let's calculate the area of the square. Area is equal to s squared, side times side, 4 times 4. So I get 16 inches squared. So now all I'm going to do to calculate the total area is equal to, let's take the rectangle, 108, minus 16, and that will give me the total area of 92 inches squared. Alright, next example. Let's go ahead and calculate the area of this region here. Now notice that it's not 100% accurate. You got a little bit of space here, a little space here, and then it goes outside here. So they're not perfect shapes, but what we can do is add shapes like this, our square and our triangle, add those known shapes, where those simple shapes, calculate those areas, and then just kind of estimate what the actual area would be. So this is an estimation, estimate the area. So all I'm going to do is calculate the area of square region A just by calculating the area of that square. These are 1 unit boxes, so it's a 2 by 2 square. So I get 4 centimeters, right? 1 centimeter square. So I get 4 centimeters squared for this region here. And I have my triangle. The base of the triangle is 2. The height is 2. So I get 1/2 2 times 2. 1/2 of 4 gives me 2 centimeters squared. So the estimated shaded area is equal to 6, and do approximate sign, 6 centimeters squared. Now that's just an estimate, and you can kind of picture, like I was saying, if you take this part, kind of cut it off, put in this little portion here that's missing, so it kind of works out to be accurate. Now we want to calculate the area on a coordinate plane, our XY axis. So we're going to start with the area for this one. So to calculate the area, well, if you identify what type of shape this is actually a trapezoid. The formula to calculate the area of a trapezoid, area is equal to 1/2 B1 plus B2 times the height. So to calculate the area, that's what we're going to do. What's B1 and B2? The B1 and B2 are the bases. Here's a base, here's a base. This is actually my height right there. So we have both bases, we have the height. To calculate the length of those, it's fairly easy to do because you just count. 1, 2, 3, 4, 5, 6, 7. So 1/2 7 plus 1, 2, 3, 4, 5. The height 1, 2, 3, 4. So you get 1/2. Make sure you use PEMDAS. 12 times 4, I would do 12 divided by 2 is 6. 6 times 4 is 24. And we're just going to say unit squared, UN squared. That's the area. That's how I calculate the area. Now let's look at the, let's go ahead and look at the perimeter in just a second. Let me delete this, cover this back up. Now let's calculate the perimeter. Remember, the perimeter is just the distance all the way around the shape. So this is fairly easy to do because all you have to do is just count. So I can count each side. The perimeter is equal to BC plus CD plus DA plus AB. Most of these are horizontal or vertical lines, so I can count those units. BC was 5. That was 5. AD was 7. Or DA was 7. BA was 4. Let's see, 1, 2, 3, 4. Yep. But the only one I have, oops, wrong place. The only one I have issues with is CD. I can't just count that one because it's at an angle. It's a diagonal. Well, diagonal line. It's not the diagonal, it's just a diagonal line. So how do I calculate the length of that side right there? Two ways I could do it. I could use a distance formula and take this coordinate and this coordinate So those two coordinates, use the distance formula to calculate the length between both of those, or the distance between both of those points. That would give me the length of that segment. Perfectly fine if you do it that way. But I'm going to use the Pythagorean theorem because I have a right triangle here. Base here is 2. The height is 4. Don't know what the hypotenuse is. So, undo that. Time out. Sorry about that. Okay. So to calculate the hypotenuse here, use the Pythagorean theorem. 4 squared plus 2 squared is equal to hypotenuse c squared, or x squared. Put a c right here. Actually, I'm going to put an x because I already used c. X squared, which then gives me 16 plus 4 equals x squared. X is equal to, x squared is equal to 220. Square root both sides, root 20. That's the same thing as 4 times 5. The square root of 4 is 2, so I get 2 root 5. So CD is 2 root 5, which when I add all of these together, I could convert the 2 root 5 to a decimal number. Be easier to work with. That's 4.5. So when I add all these up, I get 20.5 units as the perimeter, the distance around the shape. And that's how I calculate the perimeter. Use the distance formula or Pythagorean theorem after you create that right triangle. All right. 2 more slides. Estimate the area of this irregular shape. Now this one, the easy way to do this, I would just suggest counting. So here, we're going to be looking at this shape here. Let's just go ahead and start counting. Estimated full squares. So that would be 1. So I have 1 here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we're at 20 right now. Now I'm not going to count this one right here because it's not a full square. So I'll come back to that. So we're at 20. I'm not going to count this one. 21, 22, 23. I'm not going to count this one. So I have this one, and this one to come back to. Lost count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So we're at 27 right now, and I haven't counted those highlighted squares. But notice that these highlighted squares here, they're triangles. They fill up half of the box. So all I'm going to do is add them both together to get a full square. So 27, 28, 29, and we get approximately 30 units squared. Now this is an estimate, right? It's not 100% accurate. We're just saying this is what approximately the area is. So I'll give you guys probably plus or minus 1 square unit when you guys do this on the test. It has to be relatively close. If it's not super close, if you're way off, you won't get credit. But if you're within plus minus 1 units, I'll give you credit. But that's all you got to do. Just count the individual boxes. The shapes that don't add up to a full square, just combine them with the other shapes in order to get a full square. All right, last one. So this one's pretty interesting because I have this shape that I want to calculate the area of. I'm going to calculate that area, but it's really hard to do if I just try and figure out a way to calculate it just directly. So this is actually going to be an indirect area calculation. So what I mean by this is that I'm first going to calculate just a second. The area of this big rectangle that completely encloses that polygon here. So that big rectangle has a base of 1, 2, 3, 4, 5, 6, 7. Did I miscount that? Just a second. Let me double check that. 1, 2, 3, 4, 5, 6. My bad. So the base is 6 units. The height is 1, 2, 3, 4, 5, 6, 7, 8. So the area of this big rectangle here is 48 units squared. But that gives me all of this area. What I want is just this portion here. So since I've calculated all of this rectangle, what we're actually going to do now is calculate these triangles here. So I have these 3 triangles here. I'm just going to subtract them away. I'm basically going to cut them off, and I'll be left with this area of the polygon. So calculate the whole area, get rid of these rectangles here, you'll be left with the area that you want. So it's going to calculate those individual let me keep that actually, triangles here. Let me make this a little bit better. So there's a triangle, there's a triangle, there's a triangle. So let's call this one A, B, and C. So calculate the area of that triangle. We have 1/2 base times height. Well, the base here is 3 units, so you just count 3. The height is 6. So 1/2, 6 times 3, that gives you 18 divided by 2, 9 units squared. Now let's calculate B. Let's see if I can do this. We have 1 unit here, and then this is 1, 2, 3, 4, 5. So we have 1/2, the base was 1. 1 times 5. So that's 5 over 2, gives you 2.5 units squared. Now we're just left with, erase this to make it a little bit easier to see. We're left with C. Well, the base of C one, 2, 3, 4, 5. The height is 1, 2, 3. So 1/2 5 times 3. That gives you 15 over 2, 7.5 units squared. So to solve for the total area, I'm going to take the area of the rectangle, which is this right here, 48. I'm going to subtract the total added area of the 3 rectangles, those 3 numbers right there. So 9 plus 2.5, plus 7.5. So I'm going to take away all these triangles and be left with only the area of the initial polygon. So I get 48 minus 19, all these add up to 19, which gives me the total area of 29 units squared. And there you have it. Alright guys, if you have any questions, make sure you email me. We'll try and figure out the best way to address questions at a later, or just email me. We'll come up with something. Hope you guys liked it. Have a good day. Bye.